Okay, next is question number 4. What it says: prove that the function fx equal to xn, x to the power n, is continuous at x equal to n, at a particular value again, right? Now this value is also general one. Okay, so x equal to n, I have to check whether the function is continuous or not, where n is a positive integer. So basically you have to check this function, means graph of this one will break or not at x equal to n. N means positive integer, means if you check from the graph paper, you will understand that if you take x greater than, positive means what? From 0 to infinite. If you take x this one, then from this to this you have to check whether graph will break or not. Means this function will break or not, right? So how we will check without graph? With the help of limit concept, very simple. First let me write down, given fx equal to x to the power n. Now what I will do, at x equal to n you have to check, right? So at x equal to n, first find out left hand limit. Okay, now here do we need to find left hand limit, right hand? Obviously no, without that also directly you can write down. Okay, because you know that it will be always defined value. Okay, anyway let me write down left hand limit basic way. Left hand limit we will find out first. So limit x tends to n minus first fx, limit x tends to n minus, what is your fx? Fx will be x to the power n. And what is your n? N is positive, right? Any positive number you take, this means what? You are approaching towards n from the left. Okay, so left if you approach, what you will get? In place of x, can I put directly n? Because it is determinant value, right? Defined value, so n to the power n we got it. So right hand limit we will find out now. Right hand limit, limit x tends to n plus fx is equal to limit x tends to n plus x to the power n. So in this case also we will directly put n because determinant value, right? That's why I ask you whether it is necessary to write down this two or not. It is not necessary. Directly also you can write like this, limit x tends to n fx equal to, just find out, limit x tends to n, in place of fx x to the power n, and directly n you put it n to the power n. Directly you can find out without writing left hand and right hand limit. Okay, this means we find out both and both will be equal. Directly if you know, directly you can write down in this form. Okay, so this is the basic way. Okay, left hand limit is this, right hand limit is this. Now what we have to find out? Fn also, right? And this also must come. See, when you take x from the left, x, what I am taking, those value which are close to n on your left, and here what I have taken, x, we have taken those value which are close to n from the right. So from this side I have find out. Now at n also find out, x equal to n, what it will be, x to the power n, in place of x n, right? So what we got, n to the power n. Here left hand limit also n to the power n, right hand limit also, and fn also. So from this what I can write, limit, as your limit x tends to n, fx tends to n to the power n, or you can write fn. This is the definition of continuous function. Remember, whenever this is equal to this, what I can say, therefore f is continuous at x equal to n. Okay, where n is positive integer. Okay, next question number 5. I hope you're understanding a little bit now. Next question number 5, what it says, is the function defined by this. Now the function is defined what? Fx equal to x when x is less than equal to 1. When you take x less than or equal to 1, whatever x you will take, your y will be x only. Okay, whatever x you are taking, y value also will be same. That's what the meaning here. Fx equal to 5 if you take x greater than 1. Okay, now what they are asking is the function continuous. At x equal to 0 you have to check whether this function is continuous or not. At x equal to 1 you have to check this function is continuous or not, and at x equal to 2 we have to check. So at 3 point we have to check. So given function, what it is, fx equal to x when x less than equal to 1 and 5 when x greater than 1, right? So at x equal to 0 I have to check whether the function is continuous or not. This means what? At x equal to 0 you find out function, you will get some value of y, right, here suppose, then find out whether the graph will break here or not. So how you'll find? From left hand limit, from limit concept, right? So first find out left hand limit, then find out right hand limit, and at this point also you find out, means at x equal to 0 also find out whether this point is there or not. Okay, so at x equal to 0 I will write down again left hand limit, right hand limit. It's up to you whether you have understood that portion from the one which I have explained later. Okay, left hand limit, this is the basic way. If you have not understood how to write directly limit x tends to that value, then go for left hand limit and right hand limit always. Okay, limit x tends to what I will take, 0. From left I will move towards 0 and from right also, and we'll see what fx will tends to. Then fx is equal to limit x tends to 0. This kind of question we have done in 11. Fx, what we will take? This is left hand limit. Means you are coming closer to 0 from left, right? So what value you are taking? Less than 1. Whenever your x is less than 1, closer to 0 on your left means what? This values you are taking, right? So less than 1 you are taking. So if you take less than 1, what will be your fx? X. Okay, so solve this one. What you will get? 0 can I put directly? Yes, determinant value. So left hand limit, what I got? 0. Find out right hand limit. This is for x equal to 0. I'm checking whether the graph will break or not. Okay, so right hand limit also, if I find out x tends to 0 plus fx, 0 plus, if you take greater than 0, which value you will take? Just closer to 0, right? So obviously it will also less than 1. I hope it's clear. So what I will take, limit x tends to 0 plus fx will be what? Again x is equal to, directly can I put 0? Yes, so right hand limit also 0. I hope this one is clear why I'm taking x only here. Greater, this is plus 0. 0 plus means what? It's greater than 0, but which value you will take? Very close to 0, right? Remember this one, right hand limit, we used to take those value which is very close to 0. So obviously this side, or this time also, we will take those value which is on the left of 1, means less than 1 only we will take, 0.001, those things, right? So if I take those value as x, then x less than 1 means this function only. Okay, so this is also 0. So find out f of 0 now. So we have find out that x, when you tends towards 0 from the left and on from the right, your fx also tends towards 0. Fx also tends towards 0, means your fx also will be like this. It will tends towards 0 like this. Okay, now it is tending towards 0. Whether this point also will be there or not, we don't know. So this graph will continuous like this. It will not break if this point also there. Means f0 we have to find out. When x is 0, f0 will be how much? If it is equal to this one, then it is continuous. So let's find out f0. When your x is 0, which function you will take? This one only, right? So which is equal to 0. x0 we are taking, right? So left hand limit also 0, right hand limit, and f0 is also 0. So what I can write? Limit x tends to 0 fx f0. Okay, so this is the definition of continuous function. So therefore f is continuous at x equal to 0. So let's find out at x equal to 1 whether it is continuous or not. Okay, so at x equal to 1, try to do with understanding. Don't memorize all the steps which I am giving you, because see, if you understand only, then you will find it from number 6 to rest of the question from 6. You will find it much more easier if you understand, because in some question we are not going to write all the steps. Without writing all the steps, logically also we can solve some question. You will see later. So try to understand whatever I am saying here. Okay, if you are not understanding everything also, then follow the next question. In the next question also I will explain same thing. So try to see all the question. From all the question, at least you will understand something. Okay, so from that you follow the next question again. From there also you will understand, and in this way you can understand the limit concept properly. Okay, so see here what I am doing again. So at x equal to 1 I will check whether this function is continuous or not. Means what? I'm explaining this one again and again in every question through graph. Okay, but our question we cannot solve with graph. I'm explaining in the graph what is the meaning, and here what is the meaning, same. Okay, so see here, now I want to check at x equal to 1. This is 1. Suppose I want to check at x equal to 1, your function will be somewhere, right? Here or here, graph will be somewhere. So means y value, suppose here. Then at x equal to 1, want to find out whether graph will break or not, like this. And this will not break if it is, the line is like this, right? Now what does this mean? Means I will show you with the help of limit concept. How I will show? I will move towards 1 from the left, means from the right, means what? And I will check when you move towards 1 from the left and from the right, where your fx will move, whether it is moving to the same particular point or not. If it is moving, means there is chances that it will connect each other, right? So it will connect if this point is also there. If you get this tends towards this point, this tends towards this point also. If you got, after that you find out this one, then we will see that this point, if it is there, then this will connect each other and there will be continuous function. That's what the meaning, right? So what we will do, left hand limit we will find out. This means what? Left hand limit, right? A left hand limit at what you will check? 1. So as your x tends towards 1 from the left, as your x tends towards 1 from the right, I will check. Okay, so left hand limit. This time also, okay, let me just write down. Limit x tends to 1 minus fx is equal to, again I repeat, left hand limit, right hand limit, always it is not necessary. If you are confirmed that both are determinant value means what? From the limit 1 you directly put the answer, right? So obviously it will come out same. So when you know that, directly also you can line limit x tends to directly 1, then fx, instead of writing left hand line. If you write directly 1, we will understand that left hand limit, right hand limit both are same. That's why you are writing in this way. Okay, so anyway I will show you the basic way again. So minus 1 fx, what you will take? X tends to 1 means 1 closer to from the left, right? So what you will take? Fx. So this is your 1. So on your left means which value you will take? 0.9, 0. Like that, right? Means less than 1 you will take. Less than 1 means this function fx will be x. Okay, so what you will get here? Can I put directly 1 here in place of a determinant value, right? So 1. Next, right hand limit we will find out. Limit x tends to 1 plus fx equal to limit x tends to 1 plus. I am coming closer to 1 from the right now. For what values you will take? 1.0001, those values. So greater than 1 you will take. Now greater than 1, this is the function. So what will be your fx? Directly 5. Okay, so which will be equal to how much? So 1 where you will put? This is the constant, right? Constant function will be 1 only, determinant only 5. Okay, so you can see here itself, left hand limit and right hand limit, it is not same. So obviously it is something like this. If I show you in the graph, as you move towards 1 from left and from right, your fx is not moving towards same point like this. Fx is moving towards, so suppose this is 1, fx is moving towards 1 like this, okay, from the left, but from the right it is moving towards 5. So is there any chances that they will meet? Obviously no. If the point is here at x equal to 1 also, if you find out and you got y here suppose, then also the graph will not connect each other. And if after putting 1 here, if you put 1 in place of x, if you take equal to 1, then also y you will get 1, right? Here only you will get the point. So obviously this graph and this graph, you can see it is not connecting each other. Okay, so from this only it is clear that it is not continuous. Still we will find out f of 1 also, because the definition is like that, right? Definition what we used to be, x tends to 1 fx it was equal to f1. If it is like this, then it is continuous. But since from the left hand limit and right hand limit only we got it that these are not equal, then obviously this cannot be equal. Okay, limit is not equal, then how it possible, right? So anyway, this is the formality. So f1 also we will find out. F1 what it is? If I put f x equal to 1, which one function you will take? This one. So your f1 will be 1 only. So you can see this is equal to this one, but this is not equal to this one. And what was the definition? Basic definition. Remember I told you this is the definition according to book. If you get equal, this is the definition according to book, and I told you the basic is this one. Left hand limit is equal to right hand limit is equal to f of, now right hand limit, suppose you are taking x tends to c minus x tends to c plus then fc. This will be left hand limit, right hand limit and fc all must be same, then only it will be continuous function. But you have seen that these are not equal already. So what can we write down? If you write down as left hand limit, right hand limit like that, then it is something like this. Left hand limit is not equal to right hand limit is equal to f of 1. So you can see they are not equal, all are not equal, so obviously it is not continuous. Anyway, this we have find out only for formality, so that we can write like this. See here how we will write. Since all are not same, limit fx x tends to 1 not equal to f1. Okay, so if it is not 1, then what we will do? What we will write? Therefore f is not continuous at x equal to 1, or you can write instead of not continuous, f is discontinuous at x equal to 1. So you can see at x equal to 1 the graph will break. Okay, if you want I can show you in the graph also. I will plot the graph and will show you how the graph will come out. Okay, at the end of this question. So last part is at x equal to 2 also. So you will know that the graph can be like this. If you draw a graph of this function, then graph might be like this. Okay, it will break at this point. Now it might break at other points also. The graph might be like this also. It is here, right? Now at x equal to 2 also they have asked you to check. The graph might be like this. It might break at 2 also. We don't know. So we will find out whether at x equal to 2 it will break or not. Okay, this graph will break or not. So let's see. So at x equal to 2, left hand limit find out. Limit x tends to 2 minus fx. 2 minus means which value you will take? Close to 2 from your left means which value? 1.99 like that, right? So 1.99 means greater than 1 only. So which function you will take? Greater than 1, so it will be 5. Fx we will take it as 5. So if it is 5 constant function, so x where you will put, right? No use of taking function. Directly answer will be 5 here. I hope understood. If you have not understood, let me write down here. X tends to 2 minus, you will get like this. Now x tends to 2 concept when we used to bring. If this function is indeterminate, now 5 is determinant form, right? So 2 directly we used to put. Now where we used to put? In place of x. Now there is no x means what? Answer will be 5 only. Okay. Next, right hand limit. Limit x tends to 2 plus fx. Now 2 plus means greater than 2 only, right? You will take greater than 2 means this is which function you will take? Greater than 1, right? Which value, what kind of value you will take here? 2.001 like that, right? Greater value. So 2.001 will be greater than 1 or not? So function will be this one. So again you will get 5 here. Okay, so let's find out f of 2 now. Okay, f of 2 what it will be? F of 2 is greater than 1. X is greater than 1 here also, right? X greater than 1, so this also will be 5. So when your x is 2, greater than 1, right? So means x is 2, fx will be 5. So you can see left hand limit, right hand limit all are same. So therefore limit x tends to 2, fx is equal to f of 2. Therefore f is continuous at x equal to 2. Okay, I hope you can understand now. Okay, so next we will discuss question number 6, and on those questions also we will discuss in the same way. Okay, So try to get the concept from these questions, and if you don't understand anything, let me know.